Okay, we're back, and it's COMP123, Week 8, Lesson 8, Part 2. And we're talking about exception handling. Okay, I'm just going to pull that one up. So let's take a look at what is exception handling anyway. By the way, for those of you, I think it's a good practice for us to open up our Visual Studio at this point so you guys can follow along, because I'm going to do a little bit of exception handling in kind of a little project on the side here, right? Okay. Again, you can find this PowerPoint online up on eCentennial under Content if you want to follow along there as opposed to looking up here. Okay, so we're going to cover the exception class, and that's why we need to do classes first, and how we generate system exceptions. We're going to learn about object-oriented error handling methods, some of those things. And other things that it says here. For example, the toString method. We're going to try this try-parse method as well. Different kinds of methods to do exception handling with. The finally block, the whole try-catch thing. Actually, we're going to be talking about today. We're going to create a new block called a try-catch block. Right? It's going to look very similar to what we've seen before in other structures, but the try-catch block we're going to see here when we talk about exception handling is the same one that we're going to see in Java, that you're going to see in JavaScript, that you're going to see in C, other languages. It's very, very similar. It's not something that you're never going to see again. It's not in, only in C#. Okay, so what the hell is an exception anyway, right? Well, it's an error, right? Remember we did these, inputs, and I keep saying to you guys, assume that when you get input from the console that it's perfect, right? Well, now, from now on, doesn't have to be perfect anymore, right? So if you don't get perfect console input, how do you handle such a thing? What if you get a person, you're asking for a number and the person enters a letter? What do, right? Well, we have to be able to handle such an error, and that's why we have something called exception handling. In fact, if anything, when we create exception handling, it's the first time we're listening for events. This is what we call an event. And an event is going to be triggered, right, when something happens. We're listening, the computer's actually listening for any errors, okay? Listen to my terminology, listening. There's a difference between listening and handling. If I create an event listener, whether it's in this language or another language, I'm waiting, if you think about this, just like we listen in real life. I'm waiting for something to happen, right? And then when something happens, I have to react to it. So the listener piece is what we do when we and this one is built in, by the way, this event listener, which is an exception, it's built into C#. It's going to happen, and it's going to spit out a problem, right? The result, after the event is triggered, so events happen, they get triggered, and then when they get triggered, we have to respond to them. Our response is in the form of a handler. That's what we call it, all right? And the handler is actually a method, whether we write the method or a bunch of instructions to handle the error. That's all we're doing, right? All right, so this is an example of all kinds of errors that are thrown. We're going to also use that terminology. The error is thrown, right, when an error occurs. So we listen for the error is triggered, and then it is thrown, almost like a message. The message is basically transmitted to the system that says, hey, there's an error. Hey, there's an error, right? And if it's not handled, right, the system sometimes stops functioning. That's why you get that, you get an error, and then your system shuts down, right? It goes into debug mode, right, or whatever. In real life, you're not running your app in Visual Studio. You're going to run it from, you're going to double click on the app to make it run. So if an error happens in real life, it'll just crash your code. It'll send up an error, and then Microsoft, you've seen these errors before with some, I'm sure, with some Windows programs where you try and run something, it doesn't work, and it goes, it's an error, right? An unhandled exception error happened. Well, that's what happens. Some error happened that the programmer didn't handle, and then it kicks you out. So there's a bunch of different errors. So there's an argument exception error when you're listening for an argument that's to a method that's not valid. Arithmetic exception errors when you do things like casting different things. There's also division by zero errors, all kinds of format exception errors, errors in input and output where you can't find a file or an invalid file format. all kinds of possibilities. And what we have to do is listen for all of them, right? Depending on what our program is doing, we have to set ourselves up to listen for and handle any errors. How do we do that? Sounds complex, but really it's not. So again, we have this predefined, when it says common language runtime, it's the CLR that's part of Microsoft. It doesn't just work for C#, it works for VB, it works for .NET, it works for all the other .NET technologies. That's why it's the common language runtime. That's what it means, right? So here's an example. If we want to divide an integer by 0, right? Now we know you can't divide by 0, right? What happens? You get an error. You get an error on your calculator. Never mind that you get an error in your program, right? If you try and divide by 0. Why is divide by 0? It's undefined, right? We don't know what the answer is when we divide something by 0, right? Because 0 isn't a known quantity. Mathematically, if you try to divide something by 0, we don't know what that means. That's irrelevant to our, real life physics. Maybe in another dimension, divide by 0 would be okay, right? But here in the real world, in our earthly world, it doesn't mean anything, and it'll throw an error if we try and do something like that. And like it says here, I like this line, which is termination of the program is abrupt and unforgiving, because that's what happens. It just like stops your program, right? So we don't want that to happen. So here's an example of this miles per gallon program, right? That really purposely generates an exception. Let's take a look at this for a second. So here's we got an integer that says miles driven, right? And then we have another one that's gallons of gas, and then an integer that's miles per gallon, I'm guessing, MPG, right? Our console write command says, hey, enter miles driven. And then miles driven is we're going to convert from a string. We're going to read from the console with a console.read line, and we're going to convert it from a string into an integer. Okay? And then we're going to do the same thing. Here's console.write, enter gallons of gas purchased. We're going to convert from a string to an integer, right? And put it inside here. Finally, we're going to take our miles driven, here it is, and divide it by the gallons of gas, right? To find out how many miles per gallon. And then we're going to output, you got blank miles per gallon. Well, this is plenty of opportunities here for us to have an error. Which places can we have an error in this code? Yes? Anytime there's user, that's a great answer. Anytime there's user input, there's a possibility for error, whether it's on purpose or by accident. Hear me out. On purpose happens a lot, right, in the real world. They try and crash your system, right? So the idea here is to try and I would try and break your code. You know what I'm saying? If I was going to be a tester, I'm testing out your code. I'm going to try and break it as much as I can. And if it breaks before it goes into production, we have to try and fix it. We have to try and make so that it can't break. So when the end user gets your code, we've already tested it to death. And there's different ways of testing that we're not going to go into here. It's out of scope for this course. But you can set up almost like this, these user tests. And there's something called, in the real world, test-driven design, right? That allows us to actually create tests as we move forward to make sure that our code is functional. But here, there's plenty of spaces that we could run into an error. So we're getting input here and here. So those two things are a possibility. If they enter the wrong thing, like for example, if they don't enter a number, they'll enter a letter, it's gonna crash, right? And the other thing is if they enter the wrong values, like for example, if your gallons of gas was 0, you're gonna get a division by 0 error. So even here, it's not just the wrong type of input, but inappropriate input. You can't have 0 gallons of gas, otherwise you didn't drive anywhere, right? So that doesn't make any sense. There's got to be some kind of user validation or input validation here to help us out. Okay, and here's an example of that. So it's hard for you guys to see maybe, but basically the example is enter gallons of gas purchased 12, all right? And then, how many miles were driven? 300. Well, then you get 25 miles per gallon. And then here's another example. Well, I enter miles driven 300 and enter gallons of gas purchased 0. There's our division by 0 error. And it's going to give you this unhandled exception error. Actually, it won't even go there. It'll just crash your code, right? It'll do both. So how do we fix that? We've got to be able to check a variable's value, right? And if we check it with an if statement, we can do that. But even the check itself can cause an error if you don't do it right. Like if I say if this divided by this is, has an error, then it's going to cause an error. Once we do the check, if I say if this divided by this, it's going to do the calculation for you, which is it's in itself going to calculate the error. It's going to throw the error. So how do we do that? Well, we use a try block. That's what this thing is. That's what we use. We use a try block, and we have a catch block inside of there. So there's two little blocks that we're going to use, almost like an if-else, right? That's what it looks like. And then also the finally block is almost like an else statement. So let's see how this thing looks. Here's my try block. This is the syntax, right? The way it's written. Try block at the top. There's going to be this block of stuff in here. We're going to catch the exception. We don't know what kind of exception it is. It says triple X exception. Triple X exception means that you have to listen for a type of exception, right? And then here's the exception instance, whatever that's called, right? And then do something about it. So here's your code you want to test. You're testing this code. Hey, if there's no error, cool. If there's an error, run this catch statement. That's what it's doing. And that's the way you do exception handling at the very highest level. Okay. Here's an example of that, of how this thing works. So we've got the same code, but now we have this try catch block, right? So here's our try block that's surrounding or encapsulating our code. That's what this thing is doing. So this code is inside of this namespace now, this block of code, right? And in this code block, if there's an error, it'll kick out into this section here, this catch block. If there's not an error, it'll skip the catch block and continue executing normally. Okay, that's all it does, right? So you can really test for everything. Here's an example. We've used the catch-all class exception. This handles all exceptions, right? Not specific ones. And now what we're going to do is we're going to write to the console what type of exception you want. In this particular case, we're saying, and this is kind of weird that it's written like this, mempg is equal to 0. We're setting it to 0 here, right? And then we're saying you attempted to divide by 0, but that's not necessarily true, right? It's only if this happens that we're going to get this. So this isn't exactly written correctly. And I'll show you what I mean when we go and do it in code in a second. Okay, but this is the way we do things. Okay, so using this example, let's write some code, because I think there's no need talking about it. We have to test it to see what it does. All right? So let's go back into Visual Studio here, right? First of all, before we move on, any have any questions about this? Does this seem confusing to you in any way? Yes?
The catch exception, are those like, I guess, keywords within the system?
Exception is the class. So actually what we're doing is a good question. We're defining E as a variable, that's what it is, an instance variable, of the class exception. That's what we're doing, right? So E then can be accessed. I can access what E is, right? What type of exception I'm getting. Well, we'll see in the future. But exception is actually the class exception. So yes, it is a keyword. Let me go back there and try this out. Okay, so we're creating a new project. We're going to start from scratch. And what I'm going to do is I'm also going to open up a GitHub example so we can follow. If you guys want to follow me on GitHub, you can see the resulting code. When one day my Visual Studio actually does something. Oh, there we go. Fire it up finally. I'm going to create a console application, and I'm going to call this COMP123, and it's going to be Lesson 8, Part 1. Okay, that's what I'm calling it. I'll let that go ahead and do that. Meanwhile, I'll go into GitHub here, and in GitHub, I will create my new repo, right? So we'll call it the same name. So COMP123, Lesson 8, Part 1, and create my repository. Okay, I'll take this string of this URI, if I can do this properly today. I'm obviously not firing on all cylinders today. Well, let's see if I can continue without killing myself here. Okay, I'm going to go into Team Explorer. I'm going to go into Changes. Now we've created a sample, basic project. So that's what I'm going to put in here. Inside my Team Explorer, I'm going to say created base VS C# project, just like we always do. Press commit. And then I'm going to go into home, unsync commits, and I'm going to control V, and I'm going to paste this URI in here and click publish. If all goes well, what you did, then inside of our GitHub online here, you've got this file here. All the files are in here in the GitHub repository here, and if you notice, everything is in here. The only thing we really have going on here is program.cs, and it's a blank program. Okay, I'm just going to minimize that, and I'm going to increase the size of my text here so you guys can see it a little better. Right? So again, we're creating this new program, and yes, I could create a class for it right now, but just to keep it simple for this example, let's work within this, this main method. Oops. Let's work within this main method. It's really the same kind of thing. Well, I'll say I'll do a console.write. Let's just see how this goes, and we'll say, enter your age. Right? That's the first thing we want to put in there. Now, console.write is different than console.writeLine because, Tim, why? Why is it different than console.writeLine? Console.write, console.writeLine? Tim, tell me. What's the difference between one and the other? What's that? Single line? Well, close. Console.write, what it does is it doesn't go to the next line. When you go console.write, it writes to the line and it waits there. In order for us to go to the next line, you need to use console.writeLine. If you keep on doing console.write, it'll keep writing to the same line forever, right? You can also use console.write and then at the end, \n, and the \n escape character will take you to the next line, right? Okay, so that means that it's gonna look like this. Enter your age, and then here we're gonna have a little, our cursor is gonna be waiting, blinking like this, okay? Let's read it in now, right? Now, in order for you to read this in, we need something to receive this value. So we need, I guess, a variable called age. Now, if I declare it up here in my main program, is that allowed? Can I do that? The answer is not no, but just to keep it simple, let's do it here in main, right? So if I go here in main and I call this, I'm going to declare an integer value, age, right? And we don't set the integer value right now. We're not assigning age to anything. We're just making it an integer. And if I say age is equal to, and now we're going to convert, right? We're going to convert the read line statements. We're going to go convert, and then to what? To int 32, right? That's what we want to do. Open bracket, and inside int 32, we're going to kind of receive a value, right, of what's going to be converted. Well, we're going to read line, right? So console.readLine now. If I can actually type. And that is going to be converting this, whatever we get, this string from the console, we're going to convert it into an integer that goes into age. Okay? This is dangerous because we're not taking care of our user input, right? This is the normal case. Hey, I also want to create that wait for key thing, right? Wait for key, right? So let's try that. So again, I'm going to do this thing the long way, right line. Okay, and in here I'm going to do a bunch of these little, hickey do these things, and then do the same thing with console.writeLine. Press any key to exit. People are sleeping today. All right, and then we'll do the same thing. We'll kind of copy this line here to down here, to down here. I love it. I love having issues. To down here, and then so that kind of gives us a thing. And then, of course, I'm going to go console.readKey to wait for input, right? It's going to go into the bit bucket. And I might as well add another console.writeLine here, just to give me a little bit of separation between the two things. Okay, cool. I'm going to also, at this stage, I like this so much, I'm going to take this and refactor it. Here's my refactor, and I'm going to go to extract method. Extract method, I'm going to call it wait for key. My wait for key method, and press OK. Boom. It's done. Okay, so here's my wait for key method. Here, I'll scroll up so you guys can see that. Utility method, right? And in here we have our, we're asking for the user input, right? Okay, we're going to save everything, right? And when we run it, let's try this out. Console comes up. Let me just change that output because it's ugly. You guys can't see it. I'll make it white and the screen black and the font big and make it look like this. Okay, enter your age. Oh man, I wanted some separation there. What the hell? So I gotta add some things like this here. Okay, maybe a little bit of a space here, right? Let's run that again. I didn't like that. I didn't like the way it looked. Okay, cool. Let's add in my age. My age is 21, right? How about that? Press any key text. Didn't do much, right? But what happens when we do something like this? First of all, hey, we're not getting any output. That's not cool. So let's go console dot, write line. You said your age is, and of course we're going to put in some kind of interpolation variable there with age, right? Does that make sense? Yeah? Is that cool? Let's run it again. Enter your age. Put that 21 value back again. I like that age, right? If I was a vampire, I'd be 21. Okay, enter. Hey, you said your age was 21, right? I'm good to go, right? So no errors there. How about if I do it again, right? And what if I put, I make a mistake and I go 21 and I'm so excited to put an apostrophe or an exclamation mark and I press enter. It gives me an exception error. Oh man, it gives me this terrible error. What to do? Format exception was unhandled. That's the first thing that comes back, right? And this is what we want to try and avoid, right? And it says, look, it says exception settings break when this exception type is thrown. I could set it here in Visual Studio. I don't want to do that. Let's leave it as is and stop debugging. It actually creates a stopping point, a debugging point in our application in the gutter. This is where the gutter is, right, of our code. I can actually, dismiss the exception, but it'll highlight our code, and we can actually look over our code and see what the value of age is. Like right now, the value, if I hover over my mouse over age, it tells me age is equal to 0. That's the value of age, right? Debugging 101. You guys did debugging in part 1, right? Huh? Yeah? I hear yeah, right? No? Okay. So here's console.readline, right? And it's highlighting this thing. This is a breakpoint that's come up because of my error, right? And I can stop it to continue. All right, cool. Well, let's do that try catch block thing that I want to do, right? Because that's what we're learning today. So first I can do this, try, right? Oops, not truly, try. And then I'm going to kind of encapsulate it, put all this stuff here, right? All this stuff here. I'm going to put this in here, right? And then I'm going to do a catch block. This is how it looks like, in parentheses. And something I can do after I've caught the error, I've got to put an exception. So I'm going to actually put the word exception, right? If you notice, it glows this blue color, just like the console does. And of course, I've got to create some kind of instance variable. And I could call it exception or E, like they see in the book. You can call it lowercase exception or exe if you want to. Let's just use exception. We can also call it error. Huh? Error is not a reserved word. That's what it is. Now, if you notice, it says, hey, I'm not doing anything with error right now. The value error is declared but never used. Yeah. Okay. Let's print that out. Let's say something like this. Console.writeLine. And we'll say something like, you entered incorrect information. Right? That's one thing we can do. We can ignore the error, this thing altogether, and print this out. Right? So show this. Well, hold on a second. If we do this, it's going to flash and go away. Right? So I'm waiting for key here. I might as well call it again in here. Right? Why not? I always want to wait for key. I could do this. But if I know that I'm doing both things within my try catch block, I might as well not even do this. I might as well take this part out and put it down here, right? Because it's going to execute either way, right? Either way, whether I have it in here or not, it's more efficient to only have it in place one place as opposed to ask for it twice, because it's just an extra piece of code that we don't need. Okay, let's try this out now. So I'll run it, wait for key. I'm going to press my 21. Oops, yeah, we can put that in there. 21. I'm so excited to put an exclamation mark and press enter. And then it says you entered incorrect information. Guess what? My program did not break. Right? This is good, right? Now, this doesn't do anything for us, right? It doesn't ask me for the information again, right? Didn't do that for me, right? We can program that, right? So let's do a couple of things. So this is the first case. I actually want to give myself a little bit of a space. I can go console.writeLine in here, just to give myself a little bit of separation. If I try that again, and I just enter any kind of gobbledygook, right, and press enter, you enter incorrect information. You know, again, I talked to you guys about this before. Console.write commands, they're free, right? You can make your code look as nice as you like. Format it nicely, so for the professor, so he doesn't go crazy by reading the same assignment over and over and frickin' over again until he wants to kill himself. Did I say that? All right. Make it nice, in other words. Don't kill me with your ugliness, all right? The ugly code you write, right? Make your code beautiful, all right? I want your output to be absolutely fantastic. Otherwise, you know, if you guys are sleeping with the code, how do you think I feel, huh? I'm marking this stuff. Okay, let's go back to this. So a couple things here we did. We in the catch block, in the try block, again, is the stuff we want to execute as a recap. In the catch block, if something went wrong in the try block, the catch block is our message to the user when something goes wrong, okay? Now we haven't used this little error variable. Let's use this thing. You entered incorrect information, right? And then on another line, console.writeLine, we're going to enter the error. We're going to actually output the error. Let's see what happens. Can we do that? And I'm going to run it. Okay, a gobbledygook, enter. You enter incorrect information. System and format exception. Input string was not in a correct format. Look at all this information. At system number, parse int 32, la 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 la. And program line 19. Right? This isn't bad info. If you're debugging, throwing your error out to the user is good. Throwing your error out to the user when you're not debugging is bad, right? That would be a bad thing because the user's going to go, "Oh my God, my program broke. I don't know what to do. I gotta give this back," right? It's not working. So we don't use this kind of output typically to send back out to the user like this. We want to try and format our exception, right? We can also test for what type of exception. Like right now, we're just saying any old exception, we're going to fire it back, right? And we're going to look at that, how to handle those things. I'm just going to update to Team Explorer here. I'm going to go into Stop Debugging. I'm going to go into Home, Changes, and I'm going to say Added Try Catch Block Example. And Commit. I'm going to go to Home. I'm going to go to Unsync Commits and click Sync. Cool, cool. Do you guys have that? Let's go back to this. So we've done this kind of piece, if you will. Now, it outputted, we only did this piece. Now, an actual division is what they've done here. So they've actually, the input we're assuming was correct. That's another option. So a couple options here. The input's correct, but my calculations of the way I'm using the input is wrong, right? That's one option. The other one is my input is incorrect, and no matter what I do, I'm gonna exit because it's incorrect input, right? So let's do an incorrect input. So here's my age. You said your age is so and so, right? And we want to divide our age, right? Something divided by our age. What can we put? Something to divide by age, right? Something that would divide by age. What would we want to do there, right? So let's say if we wanted to say our age was how many months, right? How many months is in the number of months we've lived, right? So we can say, well, that's not really true. Age divided by something is equal to months, by 12, right? That would be bad, right? You know, so that wouldn't work out. How about this? We want to divide our age by something. Sure, let's put that in there. It doesn't make any sense, but what the hell? Console.write number to divide your age by. So please enter a number. Enter. It's like a trick. Enter a number to divide your age by, right? Okay. Console.write. Console. And now we're going to have a number, whatever the number is. So we're going to kind of create another variable in here. Int my number, right? That's what it's going to be. Or the number. How about the number? The number. And then we're going to do this. We're going to say the number is equal to convert dot to int32, and we're going to go console dot readline. Okay, there we go. That's the number, and then we're going to say console dot writeline. You said the number you entered was the number you entered is the number. Nice and easy. And let's put a separation between those two things. Console.writeline. And at the end, we'll kind of put in something like a calculation. So we'll say, we'll call it result, you know, like a int result, and we'll say the result is your age divided by the number, that dreaded number, right? And then console dot writeline, the result is, and maybe some kind of result, right? How about that? Maybe some interpolation here, and result. Make sense? And we'll also put another little break in here so we have a space between all this stuff going on. Yeah? Pretty straightforward. So we take the number, divide it by something, who knows what it's going to be divided by, and we'll have a number. Okay, let's run it. So your age, like the 21, that's good. Your age, you said your age is 21. Enter a number to divide by, we'll divide by 12, right? 12 months. And the result is 1. Oh man, what happened? How come it's 1? Anybody? Why should it not be 1? I'm trying to do division by integers. I'm going to chop off all my digits. I don't want that. I need to convert it. Okay, so how do I do that? How do I do that, Christina? What do I want to do? I want my result, instead of it being integer, I want it to be like double, right? So let's just change this to double, right? To what? Well, I did 2int over here, right? And I did 2int over here. So I'm converting it to double. That means I don't have to convert my age and the number to doubles as well, right? Right now I don't want to do that. I want to keep integers, but I want my final result to be a double. How do I do that? Well, this is back to, like, you know, programming 101, right? So first of all, I got to change my age and number is okay. I can do that, right? But I need to take the results, right? Put it in little brackets here, and I want to convert this to double, right? Now I can cast to double, right? So how do I cast to double? Like put double in brackets, right? That's my cast. So I'm going to convert it to double. Okay, that's cool. What happens if I try that now? So I go back here, 21, divided by 12. I still get 1. How come? Was that? Is that the reason why, or is it because over here I got to put a D for double? Right, my format string is not double, right? Let's try that out. So I go here. Let's try that. Is that the answer? Right? Oh man, I entered the incorrect information.
Because it does the division first and then converts to double, so it's the same. So we can move the brackets before H.
You mean this?
Yeah.
But that means, isn't this only converting H?
And afterward.
Okay, but hold on. But isn't this only converting H? Don't I care about the number being a double? Should I put it here too? Like this? This is an issue, right? It'll work without it? All right. I'm listening to Smarty over here. Let's see if it works, Smarty. How about this? Do I need this? This D? No? Sure? Okay. Let's try that out. So I go 21, and I divide by 12. Hey, 1.75, right? I get the result. Now let's try that again, right? And I go 21, I divide by 0. How come? It says the result is infinity. It didn't error out. What's going on there, right? How come that worked? It's supposed to give me an error. Let's go back and see why. In the example that we have here, everything here is an integer, right? I'm converting something in here to a double, right? And then I'm dividing it by, even if I divide it by 0, right, as an example, it's not going to, even though my error is caught, there's no error, right? If I go to 0, the result is something whacked, right? Let's try this again. Result is infinity. I like that. How about we do this? 21 and divide my age by gobbledygook. Oh, now you entered incorrect information. I'm going to get that feedback. That makes sense. And the same goes with the other way. If I go back into there and I say gobbledygook is divided by, oh, wait a minute. It stopped me right there. Didn't even let me go further than that, right? So this is a great example of how, regardless of where you make the error, whether you make it here or down here or over here, it's going to catch the error. Now, it didn't catch our error. What if we just do this? Go back to this again. So results, age divided by the number. We don't cast it at all, and we leave it as integer even. So we don't make this as a double. We make it an integer. And now we try that out. What happens here if we go 21 divided by 12? The result is 1, right? No problem. Okay, it's not right. So let's try it again. 21 divided by 0. Ah, now we're getting an exception handling happening. Why are we getting it with the integer, right, but not with the double? What's happening? We're actually casting it properly. We're converting our 0 to something else, right? That's why. So that's what we do. So be careful. Sometimes you'll expect an error, but you won't get an error, right? Let's go back and see that. So some other exceptions. So it says the exception class overrides toString. I'm going to stop in about 5 minutes. So to give you guys a break, because I know some of you are fading out, right? The user can receive precise information about the nature of any exception that is thrown. We know that already, right? So here's where we take the exception. Remember, I got that whole big gobbledygook statement, and I convert it to string. Now before, I just kind of sent it out there, and I got this really ugly string, right, of stuff. Because it's actually showing us the object, right? So what I want to do here is I want to say my error, I want to go toString, right? And when I do that, then when we get our ugly error, we still get this ugly error, but it's not as bad. If you notice, there's some of the things have been removed. But overall, you can still do what I did, error toString or error by itself, and it's going to output the best way it can. Okay. Here's an example of that. System divide by 0. attempt to divide by 0 is what they're trying to do, and you can't get it, and that's what it is. Okay. So really what we want to use is we want to use the getType method of the error to understand what kind of error we're getting. All right? And it's part of this message property of the exception class. Let's take a look at some examples. All right, so if here's again the same kind of idea of my try catch block. We know what this does already. And this time we're saying, hey, let's output the message, whatever this message is, e.message, and see what that does when we output it. E is just our error. I'm just calling it error, right? So instead of outputting a toString, let's get a message out to the console about what's going on. Let's see if it makes any difference whatsoever. You tell me. And there, enter. Hey, you entered incorrect information. Input string was not in a correct format. That is what I want. That's a much better message than look at line 19, la 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 la. You know, it's too much, right? And the same thing goes with the other error. If I go in here, instead of my error, if I put in here, you know, 21, and I divide by 0, then I get a attempt to divide by 0 error, which is a little bit better, right? Would you agree? So I think the message property, if we use the message property of the error or the exception instance variable that we're getting, I just called mine error. That's much better feedback for the user than if we just send the error out to the console. The error out to the console is pretty darn ugly, right? Let's try multiple catch blocks. Okay, this is cool. I've got a try, but here what I'm doing is I'm using multiple catch blocks to try and isolate the type of error, right? Now, if you notice, I'm not using the exception class anymore because the exception is a catch-all class. It catches all types of errors, right? Now I'm listening for specific types of errors. So my catch blocks are my handlers, right? My try block listens for all errors. Anything inside of there, any kind of error, it's going to respond to that, to the console, whatever we had in there, right? One is this divide by 0 exception, which is going to throw an error. And by the way, this that we see here, this error variable, that's the same one I use. This error variable is local to this catch block. So this error variable and this error variable, they're different, and they're never executed at the same time because only one of these errors typically would fire. And the first catch block is this one, and the second catch block is at index out of array. Index is out of range exception error. Can both of them fire at the same time? Is that possible? Let's see. So here's our integer. In this particular case, I've got an integer with a number of 13, a denominator which is 0, and the result. They're both integers. And then I have an integer array. Oh, those damned arrays, right? And the integer array, I'm initializing it with these with literal notation. This is how we initialize the array in a literal format right here. And I'm doing 22, 33, 44, right? And I'm going to take the number, whatever my number is, which in this case is 13, and I'm using that as an index, which makes no sense because there is no 13th element, right? So it's going to error out this way too. So let's try and do that. So let's go back here to our code. First of all, let's change our message because I want to respond to division by 0 errors because that's an option, right? We'll leave my exception error as is, right? This exception. And let's add in another type of catch. So I'm going to copy and paste this whole thing. Here's my second catch. And this time, instead of an exception, because we've already caught that one, let's put in there division by 0 exception. Let's try that. And hey, let's see what it says. It says the exception that is thrown when there is an attempt to divide an integer. A previous catch clause already catches all exceptions of this and of a super type. So I can't do it in this order because I already catch everything right. Remember, this is my catch-all exception. If I just use the word exception, it catches it all. If I use a specific one like this one, it catches specific ones. But I've already caught it here, so this one's never going to fire, and that's why it's giving me this error. So I got to move the order of these things. So I'm going to move this one here down. I'm going to cut this out and move this underneath that one. And this is my catch-all exception error, right? That doesn't give me an error because First, I'm going to check if it's dividing by 0, and then I'm going to check for everything else. So if I know this is divided by 0, I can put something in here like this. Hey, don't try to divide by 0. Right? Some funky error message, customized error message for these people who are trying to divide by 0. These crazy people. Who are they? Right? And let's run this thing. So if I say age is 21 and I'm trying to divide by 0, it's going to say, hey, don't try and divide by 0. Attempt to divide by 0 because I'm also outputting my error message. Okay, cool. So it caught that error. What about if I do both? If I try and not only divide by 0, but inside my second option, enter number to divide by your age, I put in some gobbledygook, right? Can I do both now? Like, for example, I can put age 21, and then instead of divide by 0, blah, right? So it says you entered incorrect information, input string was not in the correct format, right? Okay, that's cool. Let's try that again and try both things wrong. This one, oh, it stops me right away. It doesn't allow me to put something in there. So it kind of stopped me before I got to enter divide by 0 because it fired an exception, right? It triggered an exception, my entry. I want you to think about the words that I'm using here because I'm giving you some new lingo, right? My entry triggered an exception. It threw an exception. Basically, the system threw an exception, and I caught it with my catch block. Throw, catch. That's why it's catch there, right? My catch block catches the exception that's been created, that was generated, right? And then I responded to it with your input string was incorrect format. So I get multiple catch blocks here. One that specifically tells me what to do, and the other one that catches all. All right. This is cool, but the one we didn't handle was this index out of range exception because we don't have an array, right? And again, if you'll notice, if I go back to the example, if I go back here, it says in the first catch block, attempt to divide by 0, right? It says 2 errors. Why does it say 2 errors, right? And well, the class is called 2 errors. That's why it's called, right? And if you notice, this first one, right, this result is dividing by 0, hits this first catch block right away, right? So this is the one that fires. It doesn't get to this one. Okay, and here's another one. If I switch it around, the order of this thing, and I switch them around, then the second one will fire, right? If I put it the other way around, the first one will always catch. You can't respond to both types at the same time. One error will generate, the catch will catch any one of the errors. It'll generate an event, right? The message will be generated to the system that says, I'm going to throw you an error. I'm throwing you an error. Hey Neil, I'm throwing you the error. Catch it. Okay? Catch, man. All right. And then what happens is, so Neil caught the error, right? He's acting as my catch block, right? And the reason why it's happening is because, you know what? If I'm the system, I'm generating this error. I'm creating my message that's throwing the error, and I need a receiver of that thing. If I don't have a receiver of the error, the system is going to cake out. It's going to crumble. So that's multiple catch blocks. Okay, cool. And again, this is the catch-all, right? This will catch everything. So this is the way we do it when we have a specific catch block that we're going to use, a specific error that we're listening for, and then we have an idea of unreachable blocks. And the reason why we have unreachable blocks is because, you know what? Once we generate an error, anything after that error we won't be able to continue, right? So think of it this way: couldn't we then have multiple try-catch blocks for different user input? And the answer, of course, would be yes, right? And that's the way we would capture. Each error could be captured separately, and we can continue generating the program. Let's take a brief break here before everyone cakes out, right? And then we'll come back in like 5 or 10, okay?